Hello class, and welcome to the second part of our lesson, Earth's days, years and seasons. As you well know, this is still Model G, Space Science, Unit 3, the Earth, Moon, Sun system, and our lesson is still Earth's days, years and seasons. Last time we talked about the days and the years, and how each rotation causes day and night, and how that 1 day 1 night cycle is counted for us as an Earth day, and in astronomy of course, and 1 year is about 365 days. And on the next slide now, we're going to get to know about the learning objectives. Now, the first learning objective we're going to start with is the same that we ended with the first part, which is Earth's tilted axis and solar energy. We're going to talk more about that. We know already about the tilt and how the tilt affects the rotation and affects the length of days and the amount of sunlight each part of the Earth receives. Now we're going to talk about more of the effects of these things. Now we're going to explain how the tilt of Earth's axis affects hours of daylight, which parts have more daylight than other parts. We already mentioned that in the first presentation. We're going to revisit it now. And then we're going to talk about the seasons, how the seasons are caused, and then finally we're going to describe what equinox is and what solstice is. And to start it all with, I remind you of those two pictures that you see there. This is the first picture with the sunlight coming from the left side, and the other picture is the same, but the sun is placed on the right side. Why did I choose these two pictures? I chose them so you can see that the sun, as the Earth also rotates and revolves around the sun, the Earth receives sunlight sometimes from its right and sometimes from its left. And as you can see, the rotation of the Earth, whether the sun is on the left or on the right side of Earth, the rotation is going to cause the day and night. Okay, half of the Earth is going to be at night in the darkness, and half is always going to be facing the sun and experiencing daylight time. But which days are shorter? Which days are longer? Take a look at the other picture next to those things. You can see that when there's when the sunlight is from this side or from the left side, the right side, you see that the North Pole is tilted towards the sun. When this is happening, that means in the northern part or the northern hemisphere of Earth, the days are longer. Take a look at the day, how it starts here, let's say, and then ends right about here. This is where darkness begins. Take a look at the same thing or the same distance, the area at the same distance from the equator. There it is here. It has a short day, a shorter day. Look at that. The day doesn't even reach the half of the whole cycle. The North Pole, the South Pole is totally in darkness. Light doesn't rise on the South Pole. Why is that? Because the North Pole is tilted towards the sun. That makes the South Pole totally in darkness. All the parts that are from the equator and north in the northern hemisphere, they have the day increased by some hours, and the southern hemisphere has the night increased by several hours. So as you can see, the rotation of the Earth causes night and day, but the tilt of the axis of Earth causes longer days or shorter days. Okay? So basically, the number of daylight hours is depending on the location. Where are you located on the surface of the planet? And whether this location is at a time where Earth is tilted or the north hemisphere is tilted towards the sun or away from the sun. Okay, now let's go back to the first picture right here. In this picture here, the north, look at the north pole, the North Pole is tilted away from the sun. So the shorter days are in the northern hemisphere and not in the southern hemisphere. Okay, so you see the difference? In this picture, I have the North Pole totally in darkness. 24 hours of darkness. The sun will not shine on this North Pole at this time. While at this time over here even, I have the North Pole tilted towards the sun. And if it is tilted towards the sun, that means it's going to receive 24 hours of sunlight. Okay, now of course the more it spends time, or that region or area of Earth's surface spends time under the effect of the sunlight, the more energy is going to have, the warmer it is going to be. Okay, and if it is warmer, that means it is going to be a different season. Okay, we'll talk about that in a moment, but before, let's continue. The more that we have sunlight, the longer the day is, of course, and the longer I have energy to store on the surface. But on the equator, if you well can see, the days are always equal to the night. Look here, see, the day and night are always equal. 12 hours of daylight and 12 hours of nighttime or darkness. Okay, that means that if as I told you, the north is tilted, or the part that is tilted towards the sun of the earth, the northern hemisphere is tilted towards the sun, it will receive more daylight hours, more sunlight hours. And if it was tilted away from the sun, it will receive less daylight hours, and subsequently the days will be shorter than 12 hours. Now on the next slide here, we're going to talk about seasons. How do seasons change? Now, the very first time you look at the picture on the top, you see I have 4 seasons: autumn, summer, spring, and winter. Why are they arranged in that sequence? Can we change their places? Actually, no, we cannot change their places. Why? Because I have to look at the planet Earth at each time. Now, if I look at planet Earth at position number 1, what do I see? What do you see? The northern hemisphere, look at it, the northern hemisphere here, it's in darkness. That means all this way here is autumn. It's preparing to be tilted away from the sun. And once it finishes and tilts away from the sun, now it is in darkness, and we spend winter in the northern hemisphere all through until we get to number 4. On number 4, you see that the northern hemisphere is not tilted towards the sun, and it's not tilted away from the sun. It is half and half. So it is in the middle. That says that half of the South Pole is also receiving half a day of sunlight. And so it's half-half. On this particular point right here, what do I have? I have equal days and equal nights. And we continue. And as spring begins, the equal day and night occurs, and then spring begins, and by the end of spring, I have the northern hemisphere right here totally tilted towards the sun. It is totally tilted towards the sun, and so what happens here? It's the beginning of summer, and summer is there all that long until the northern hemisphere is not tilted nor towards the sun, nor the southern hemisphere tilted towards the sun. Okay, so it's equal days for both. Okay, and so I start autumn all over again. Now on the next on the bottom, what do I see? I see number 1 is winter solstice. Number 2 is autumnal equinox. Number 3 is summer solstice, and number 4 is vernal or spring equinox. And those three those four, let's say, days or periods of time are very important because they mark the change of one season into another, the passage from one season into another. And so what is solstice? We will figure that out in a moment. What is equinox? We will figure that out in a moment too. But we have two solstices and two equinoxes. Okay, two equinoxes, one that marks the beginning of autumn, and that's number 2, and one that marks the beginning of spring, and that's number 4. While on solstices, I have number 1 to mark the beginning of winter, solstice for winter, winter solstice, and 3 marks the beginning of summer or summer solstice. Okay, on the other part or on the other picture, you see the winter solstice happens in December 21, 22. The March equinox, the vernal equinox or March equinox, it happens in 20th and 1st of March. June 20, June 22 is the summer solstice, and autumnal equinox or the beginning of autumn, it happens in September 22 and 23. Okay, so what is a season at the very beginning? What is a season? As you can see, I have 4 seasons. What's a season? A season is a period of time where I have, let's say, similar temperature and humidity conditions and weather conditions. Okay, basically we base all that on how much daylight hours we receive during those let's say seasons. Okay, so for example, in the summer I have long days, I have hot temperatures, I have high humidity. Those are characteristics of the summer. While in winter I have cold and shorter days, and I do not have as much humidity. In autumn and spring I have moderate temperatures, moderate humidity, but the autumn is always a little bit colder than spring. Okay, and it has a lot more precipitation than spring. Okay, and so this is what seasons are. I have 4 of them. I have 2 solstices, 2 equinoxes that we're going to get to know further just by reading this. Each season is characterized by a pattern of temperature and other weather trends, as I told you, humidity and daylight hours, and whether it's hot or cold. And then we experience seasons due to changes in the intensity of sunlight. I told you that already. It depends on the amount of sunlight that we receive in each of those seasons on the surface of the earth, and that's what really gives me the sense or the experience of summer or winter or spring. It's the amount of sunlight that the Earth's hemisphere, the northern hemisphere, because we live on the northern hemisphere, or the northern hemisphere, how much sunlight does it receive during that period of the year? Then I would know what kind of season am I in. Okay, of course, it says, continuing here reading, we experience seasons due to changes in the intensity of sunlight and the number of daylight hours as Earth revolves around the sun. So as Earth revolves around the sun, we experience seasons. As Earth rotates around itself, remember with me, we experience day and night. Coming up next is what an equinox is. As I told you, at an equinox, the sunlight hours are exactly the same. The Earth is not tilted towards the sun or tilted away from the sun. So the daylight hours are exactly equal to the nighttime hours. And so I spend 12 hours day, 12 hours night, and I have moderate temperature and moderate conditions, weather conditions. And that's what is so trendy about spring and autumn, with the exception that autumn is followed by winter, of course, and it becomes colder and colder and colder, while spring starts as a little bit fresh and cold, but then it turns into hotter and hotter and until it reaches summer, of course. And then they say as Earth moves along its orbit, the sunlight reaches more of one hemisphere than the other, and then the solstice happens. As I told you, spring will progress and autumn will progress, of course, bit by bit until the solstice. Spring ends with the summer solstice, and autumn ends with the winter solstice. Okay, and what's the winter solstice? It is the days where the spring actually ends and summer begins. Meaning, it will mark the a time or the day where let's say the day time hours or the daylight hours will be longer than the start becoming longer than the nighttime hours. So during the spring, I'm going to have 12 hours of daylight, 12 hours of darkness, while in the summer, as the summer begins, the days are going to become longer and the nights are going to become, or the darkness hours are going to become less and less and less until we reach the autumn. What's it called? The autumn equinox. And so we start in spring, and spring I have very short, at the very beginning of spring and the end of winter, I have very short days and long nights. That will start to change. During spring, at the mid-spring, I will have 12 hours of day and 12 hours of night. And then after I get to the end of spring, that is the longest day I can have on June 22 or June 20, between those two dates, June 20 and June 22. I am going to have the longest day, and then afterwards I'm going to spend summer. During summer, the days are going to start becoming less long, bit by bit, until I reach to the autumn equinox or autumnal equinox. At that time, what happens? The daytime hours are exactly equal to the darkness hours. That's why I call it equinox. Again, okay? And then the days become shorter, bit by bit by bit, until I reach the shortest day at the beginning of winter. Okay? And so on. Or until I reach an equal day and night at the beginning of winter, sorry. And then after the beginning of winter, that's the beginning of winter is marked by the winter solstice. The nights are going to grow longer and the daylight hours are going to grow shorter. And so things get colder because this hemisphere now is getting less daylight hours and more darkness hours, meaning it's going to get cold. I hope that made things easier for you to understand, but please focus on having 4 seasons. Focus on having 2 equinoxes. 2 equinoxes means that the day and the night hours are equal. Day and night, 12 and 12 hours in the autumnal equinox and in the vernal equinox. Okay, at the beginning of autumn, at the beginning of spring. And then in the solstice, I have the days becoming let's say in the winter solstice, I have the days becoming shorter, while in the summer solstice, the days becoming longer. Okay, so at a solstice, the area of sunlight is at a maximum in one hemisphere and at a minimum in the other hemisphere. So a solstice marks the area, or marks the concept of having a lot of sunlight on one hemisphere and a lot of darkness on the other. So it's not equal sunlight and darkness anymore. It's not like the equinox. It's the opposite side of the story. Okay, one last time, going through the cycle. Number one, it is the winter solstice. At that time, I have the northern hemisphere having a lot more darkness than light, meaning at that point we start having the longest night and the shortest day. Bit by bit, and as winter progresses to go to the spring equinox or the vernal equinox on number 4, what do I see? I see that the spring, at the beginning of spring, the daylight hours are now equal to the nighttime hours. Very good. And then Afterwards, I continue from 4 to 3, just like the arrow tells me to go from 4 to 3. During spring, what happens? At the very end of spring, I start having the days longer, bit by bit, at the very beginning of spring. And at the very end of spring, I have the longest day and the shortest night. In this case, I will have the northern hemisphere tilted towards the sun. As you can see in the picture, the northern hemisphere, there it is tilted towards the sun. It is always in sunlight. And that marks the beginning of summer. The longest day and the shortest night are here. It's the summer solstice. Number 3, summer solstice in June 20 to 22. And then we continue. The days are growing shorter and shorter. The nights are going bigger and longer and longer. And so until we get to number 2. Once we get to number 2, at that point, I have an equinox where the days are 12 hours and the night or time is 12 hours as well. So I have an equinox again. But this equinox marks the beginning of the cold season, not the warm season. So the nights are going to become longer after this point, and the days are going to become shorter after this point, of course. At that point, which is the autumnal equinox at September 22-23, the days are equal to the daylight hours are equal to the nighttime hours. As we progress even further, we go into autumn, and during autumn I have the days growing shorter bit by bit and the nights growing longer until I reach the winter solstice. At that time, again, it is the longest night and the shortest day, and that would be on the December 21, 22, which is the winter solstice again. Okay, here it's the same thing. I have 2 marked equinoxes, March equinox and the September equinox, or the March equinox means what? March is the beginning of spring, so this is the spring equinox or the vernal equinox, and this is the September equinox or the end of summer or the beginning of autumn. This is the autumnal equinox right here. Okay, now here I have June solstice, which is the beginning of summer. Look at the northern hemisphere. It is tilted towards the sun. It is always in the sun. And here I have the northern hemisphere tilted away from the sun, and that begins the winter, or it marks the beginning of winter, and that is the December solstice. Okay, and so during September equinox, where's September equinox? It's over here. What do I have? I have not equal hours of daylight and equal hours of nighttime, and that's an equinox. And of course, that will be the beginning of autumn. And during autumn, I'm going to have longer nights and shorter days until I get to the December solstice right here, where it is the longest night, just like I said in the slide before, the longest night right here in the December solstice. Next is the March equinox, and during the March equinox, what do you have? You have the same thing. I have equal amounts of daylight and nighttime hours here in the September equinox, and I also have the same thing in March equinox. Why? Because both of them mark equal amounts, 12 hours of daylight and 12 hours of sunlight. Daylight and nighttime. Okay, and on the equator, I always have what? I always have what? Whether it's solstice or equinox, winter, summer, spring or autumn. On the equator of Earth, it's always the same: 12 hours of daylight and 12 hours of nighttime. So at the December solstice, what happens? The North Pole leans away from the sun, as I told you. There it is, leaning away from the sun, and it is in complete darkness. At the same time, when the North Pole is away from the sun, the South Pole will be totally in the sun. And on the June solstice, it's the opposite. I see the northern hemisphere and the North Pole totally in the sun. At the same time, I will see that the South Pole is totally in darkness. Okay, and that ends our lesson. Thank you for listening, and I am going to share with you also these helpful links that you can visit. Some of them are pictures, some of them are videos for you to get to know more about the seasons and how they change. Thank you very much and have a very good day.